I'm using finance and operations here as a collective term throughout the course of this presentation for the cross-app capabilities that applies to products like Dynamics 365 supply chain management or Dynamics 365 finance, etc. Let's walk through the objectives of this tech talk. First of all, we want to do some level setting here on why you should utilize the batch framework at all. Another objective is to reiterate on some important aspects of batch parallelism and common approaches to such. Then get you grounded with some patterns and anti-patterns, which are basically based on the learnings from thousands of implementation out there, which we have now up and running in the cloud on our finance and operations service. Finally, with the next objective, we want to come to what made the title of this tech talk, which is an overview of the new batch management framework features we introduced throughout the last couple of updates. Last but not least, we also want to give you a brief insight into our roadmap so that you have a rough understanding, at least, of where we are heading to. What we won't give you a detailed how-to on batch schedule management, for instance. We won't cover other frameworks than batch that allow also parallelism and asynchronous processing. So we really focus on batch here. And of course, we cannot provide a silver bullet to address your specific business scenario in this format, or magically schedule the entire batch schedule for you or something like that. So you should take the input and insights provided here within this presentation and apply as appropriate. Ultimately, an experienced solution architect or technical architect in the role is that person who is responsible to apply the principles we talk you through out of the project. So let's get started. In a nutshell, batch processing is a mechanism to run automated processing of tasks in the background. It provides the ability to create recurring schedules, execute tasks in parallel or sequentially, and you can, of course, create dependencies between task and a job and execute based on conditions. In the next section, I want to mainly focus on the parallelism aspect of the batch framework itself and not provide you a deep dive insight into the framework architecture. So there are elements of it in it, but the goal is really to focus on the parallelism aspect, because that's quite a significant one. Parallelism is ultimately not only the future, so parallel computing is reality already. Servers have more and more processors, and processors have more cores. So there is absolutely no doubt about that this trend will continue. Almost every day, new innovations are upcoming, and the beauty of the cloud is, think about that. We are democratizing at the end large-scale compute power, and that enables elastic scaling in new ways that we would never have imagined in an on-prem world a couple of years ago. Yeah. Now, here comes the caveat. None of these matters if your code runs in a single sequential process. Of course, single sequential processes can benefit from other improvements like faster clock rates and so on. But keep in mind, in the end, each finance and operations session runs sequentially in a single thread if you don't apply any kind of parallelism to that process. So having your customers or your customers' users in front of a screen waiting for a lengthy operation that is not leading into non-optimal user experience, but ultimately also harms productivity. Now, there are different ways to introduce parallel and asynchronous processing within finance and operations so that your users can continue to be productive, But keep in mind that if you utilize, for instance, the run async framework, the execution of code at runtime will still be handled on one AOS node for a given execution of a process. And you need to be also careful not to overuse it. Because when you're running and using run async, it is important to understand that the ramification and factor for these through appropriate throttling in the consuming code needs to be taken into consideration. Overall, I would say that the batch framework is still the go-to framework to utilize a broader farm of batch nodes and to provide further scalability to your solution. So here in that graph, you see a sample of batch framework utilization with a invoicing batch job, for instance. And this graphic should give you an idea of how tearing down a monolithic process like that invoicing batch job would distribute within the batch framework. So take large volume invoicing batch job, and it is ultimately, first of all, distributed into logical group of orders, so kind of buckets here. Yeah? And these are attached to batch tasks. And as illustrated here, there could be obviously n number of tasks generated out of the split up. So what has been a monolithic process before is now tiered down into and split up into smaller chunks. And these tasks will then end up in a task queue. And from that, the different batch services can pick up from. Each batch node will then be able to execute tasks in parallel, and that is ultimately combining everything into a quite scalable model, considering that more and more batch nodes can be added here in that scenario. So when designing functionality that is supposed to run in batch, it is then quite important to consider that there are different possibilities to break down such a monolithic processes into small manageable fragments. And these fragments are then providing an ability to be processed independently in parallel. Think mainly about three common approaches to achieve the breakdown into manageable fragments here. Individual task modeling, batch bundling, top picking, and yeah, there would be a fourth one where you combine batch bundling and top picking. These should not be any surprise, as they do already exist since years. The information is also out there, but however, they still apply, and they still highly influence the runtime behavior of a given task. So they need to be understood. And not only if you create new batch classes as part of your implementation, so creating extensions, but also when running standard batches or standard functionality that can run in batch, because you want to understand why a certain process is behaving in a certain way within the batch execution itself. Each of these approaches come with pros and cons, and they should be selected wisely depending on specific type of workload that you want to address. In the next couple of slides, I want to give you an idea about how each of these approaches behave ultimately against different type of workloads. So in individual task modeling, parallelism is achieved by creating a separate task for each work unit. So you will have a one-to-one mapping here between task and work item. And as the number of tasks are not fixed, it will scale up or scale down along with a batch schedule, either using yielding or extra resources here. Keep in mind that even if there are pros, for instance, that large work items won't be bundled together with smaller ones, which could potentially delay processing of smaller work items. there's still a risk of putting significant pressure on batch framework itself when the number of tasks is huge. Imagine thousands of tasks that can be an extra overhead to the batch framework, which might impact the overall performance then quite severe. We have, for instance, based really early versions and previous versions of the product. There we had, for instance, MRP running on this individual task modeling, for instance. Some other pros and cons for this approach are that individual task modeling will work fine with uneven workload. And of course, it is really simple to write. There's not much custom logic or complex logic which you need to apply for grouping here. It can scale up and down along with the batch schedule and best fit to create dependency among the work items. The graph on the right shows you an individual task modeling, or shows you that individual task modeling is adding quite some increase in runtime for even workload with a large number of entities that are processed and hitting the batch framework. Next part is batch bundling. So in this approach, there's a fixed number of tasks created, usually while scheduling the job itself. And the batch framework is currently designed in such a way that you can add or shrink the number of batch threads, either automatically through batch server schedule or manually by the admin. And because the number of tasks are pre-created, it will not scale up or down along with the batch schedule, either using yielding or extra resources here. Batch bundling works fine for simple, even workloads, and there's no heavy extra maintenance required by the application code, and it does not typically pollute the batch tables a lot. Some cons are that a fixed number of tasks is created while scheduling the job, and it is preventing elastic adjustment. So for uneven workload, you may need to create complex algorithm to find equal distribution of the work, and that can be quite a complex activity. In some applications, it might even be almost impossible to distribute the workload evenly. So in the graph on the right, you can see what the effect of this approach on runtime behavior is if you run the uneven workload against the batch framework, as the completion might be waiting on some threads of a bigger bundle in a certain runtime execution. Last one I'm going to show here is the top picking approach. So there's also a fixed number of tasks created usually while scheduling the job, and there's no pre-allocation done as such, but you're utilizing a staging table for your work items. So your workers threads will then just fetch the next available task from that staging table. And because the number of tasks are pre-created, it will not scale up or down along with the batch schedule. This approach works quite fine with uneven workload and is also relatively simple to write. It doesn't overpollute the batch framework a lot, as the tables, the staging tables which you create are simply offloading some bits of it into your logic around the staging. And the staging table, of course, on the other hand, has cons, as not only think about the code maintenance, for instance, of it. When a large number of short work items needs to be processed, tracking the work items through the staging table affects also performance and ultimately could affect then also the throughput of such. So in this graph on the right, you see that the runtime behavior of a very large workload with a large number of work items is shown there. And this is like let's say 2 million work items here. And you can see that for a very large number of work items, neither top picking nor creating individual task model will scale. So emphasize these principles or approaches, and there's a really good blog post series out there, and you find links to it at the end of this presentation. Next slides, I will walk you through some high-level key patterns and anti-patterns next. So you want to start identifying batch workloads in your project early on. So even in early phases of your projects, you typically have a first idea about high volume processes of your to-be solution that can or should or must run asynchronously. When then getting into designing your solution, many of the solution architecture areas like process, application, data or integration architecture will then further contribute to the list of potential batch workloads. So it's a little bit collecting them throughout the early phases already. And heavy, high volume or lengthy processes are of course the ones you want to consider. So there it's quite obvious. Another important aspect is that you also start crafting your end-to-end batch schedule as soon as possible. You want to take non-functional requirements and your operational schedule into account to be able to get a first understanding about what can or needs to run when. Possible nightly batches or batches that can run in other time frames without interactive usage can then be defined, classified. You want to watch out for possible conflicts of heavy batch though, and interactive usage of your solution. So depending on your global scale of that solution, that's an important aspect. You want to understand when are interactive use cases and workloads hitting that environment and what kind of batch workloads are potentially in conflict to it. If identified a bigger issue here on possible runtime due to design reasons, you might need to invest additionally into tuning, or in worst case, it means that you identified a gap early on in your project. The next pattern is that you should fine-tune logical grouping and sequential order of your batch schedule. So heavy workloads that are touching the same areas of the solution might run into conflicts during runtime, and you want to keep an eye on what can and should run at the same time and what simply not. Optimize first before running in parallel. So you have a process that is not tuned and doesn't perform well if you're running it single-threaded. If that is not fine-tuned, then of course it is quite hard to reach efficiency in runtime behavior, also in parallel execution. So first tune it and then get into scalability of parallel execution of it. And this is especially true for time-sensitive and business-critical processes, of course. Simply, you might need to invest more time to these to meet your non-functional requirements. So there's some work implied. Do fine-tune the configuration of standard processes running in batch as well. So it's not only about your custom code and your custom batch-enabled workloads, but as you tune code and design of your custom batch processes, you want also to fine-tune configuration of standard process like release to warehouse, invoicing, or DMF with bundling, or even things like the index maintenance jobs. You want to fine-tune the execution and runtime of such. Train your end users to run relevant processes in batch. Yes, you could argue that some processes in finance and operations should not be able to run in interactive mode at all, but keep in mind that this is a standard ERP cloud service that is used against various different solutions with huge diversity in process, industry, etc. So you need to ensure that end users are aware of processes that they better have to execute in batch. On the other hand, ensure that also there's awareness for how to configure batch itself. So the users needs to know at least, for instance, that certain heavy batch activities should not be executed during main business hours, or that a certain batch process should run against a specific batch group to limit the broader impact to the rest of your compute resources. Do not assume batch maintenance is on Microsoft. So there's clearly a shared accountability on batch maintenance here. And obviously there is a service description where you can find more general information about the different accountabilities of each parties for the SaaS service. And while we own parts like, for instance, the infrastructure in the backend, think about that Microsoft cannot know if certain workloads in your solution should run in batch or not. We don't know your detailed non-functional requirements. And take a scenario, for instance, where a certain batch job is failing because of bad data. Customers own their data, and there's almost there's most likely a valid reason for this batch job to fail in that scenario. So Microsoft cannot interfere here a lot and would never manipulate your data, and not only because it could harm logical integrity of your data itself, of course. So keep an eye on monitoring of batch, not only error rates, but also anomalies in runtime. Especially true for critical batch jobs, of course, and take appropriate action. Don't just look at it. There needs to be investigations why certain error rates are increasing, why certain runtime is suddenly not optimal anymore, before you're hitting any bigger harm for your business. Cleanup mechanisms of the framework, like our famous batch history cleanup, they need to be also configured and executed as well, and that's on a frequent basis. So Microsoft is not owning configuring that for you. Do not flood the batch framework itself. So even with lots of improvements, and we are touching base on that in the next slides. Even with that, there are limits, and there's throttling happening ultimately. So even with improvements, you should simply not kill our framework. So I've talked you through different approaches on the previous slides to show you what the effect of different approaches to runtime behavior are. So you clearly see that there are many variables to such, and still as a thumb rule, you should run batches less frequent as possible. So not everything needs to run every minute, and there are new frameworks available, like for instance business events, that you can utilize to significantly reduce the need to schedule frequent batch jobs, for instance, for polling. So if something doesn't need to run every minute, don't schedule it for it. Start with the least frequent approach. Test scalability and tune your batch framework. So I'm not going here into details, but there are really couple of really good tech talks which are out there, like the performance key patterns and anti-patterns for Dynamics 365, or the performance testing approach. And we have put them into the resources at the end of this presentation. So highly recommend you to watch them so that you get some concrete examples of tuning activities. Do fine-tune batch server allocation, or in the new shiny world that we will cover in just a couple of seconds, you want to fine-tune the scheduling priority of batch groups. Remember that batch jobs will spin off batch tasks, so which are then executed within the context of a certain batch group. So it's quite an effective mechanism for you to fine tune on top of settings of standard batch jobs or on code and other tuning activities on your custom ones. So there you have still lots of possibilities to have a bigger effect on execution behavior. Do not assume unlimited scalability. So there is a limit on how many batch threads your solution will be able to handle. And of course, you know, if you have a heavy process which needs to process a huge amount of data, even in parallel execution, some things will take time, and you need to plan realistically with that, and keep and test the runtime behavior, and then plan accordingly, and not just assume that everything will just run. And especially if you don't have the non-functional requirements collected or defined within your project, yeah, that can become a little bit troublesome, because you don't know exactly where to focus on. So therefore, take these kind of patterns and anti-patterns into account, and then you're not ending up in a bigger surprise later on. All right, with that, I'm going to hand over to Par.
Thank you, Timo. So I will talk about the new features we have introduced over the last year or so from PU25 and onwards. So to start with, I just want to talk a bit about what is the reason behind that we have worked with this specific set of features. And I think the answer lies in the application and how our customer base have changed over the time. So finance and operations used to be a medium to large business solution. We have for some time, even back in the days, had some enterprise customers, but now it's been gradually moved into being a complete enterprise solution. That also brings high volume with batch loads, and we also have the fact that the application itself has grown quite significantly when it comes to the breadth and the depth, adding new solution, new verticals, and all this results in additional load. So a lot of the features that I will present that the team has worked with is about reducing contention or locking and increased the throughputs. It's also about making it easier to orchestrate the batch processing and automate the optimization and utilize all our resources or your resources. We're also trying to modernize the batch management, and one important part here that we're working with is the decoupling of the batch infrastructure. So you will see some enhancements coming already now, but this is also a very important part to prepare for future capabilities that we want to support. And that is something that Reva will cover at the end of the sessions, but I just want to mention that this can enable things like the batch scheduling as a microservice, moving to elastic compute, or be able to reach near zero downtime. So looking at the features, I will cover most of them on pretty high level, but when it comes to reducing locking or contention, in PU31, we have the batch framework contention reduction. This is still something that you need to turn on in feature management, and I will come back to that. It's not in preview, but it's still managed based on enabling this in feature management. And that is especially important if you are experiencing these kind of issues with your batch processing, to evaluate turning this feature on. We have been working with many customers over the last couple of years with that has put stress on our capabilities, and these are also coming out here as learning, and this has been a game changer for several of our customers with high batch loads. And on a high level, what this feature is doing, it's moving the processing to use what I would call like snapshots or temp tables to prevent the blocking or contention, and then do the update separately. On a similar end, we have the batch load balancing that was introduced in PO29. So this is an example where we try to optimize the way how tasks are distributed between servers to make sure that we at any given time utilize the full available capacity. That is there as a default behavior. We have added a possibility to abort an executing batch job in PO27. So if a batch job is in status canceling, it could still be running for a very long time. And now we have added an option to be able to abort that. This should work in most scenarios, but it's also important to be aware of that this is something that you shouldn't do without understanding the implications of aborting a batch job. So depending on what the batch job is actually doing and at what time you would abort it, this could lead to data corruption. So it's important to be aware of the implications of aborting and executing a batch job. Before PO25, we used all available AOT servers that could be playing a part in scheduling the batch jobs. That also led to contentions, and to improve the situation from PO25, there is only at a specific time one single batch scheduler, meaning one AOT is giving this task to orchestrate the batch jobs scheduling. In PO25, we added quite a number of features, and an important part here is the enhanced batch form. That makes it a lot easier to find out what is going on or what has happened in the batch execution. So I will show some example of that in my demo. But it makes it a lot easier to search and investigate batch jobs. It also provides a better user experience, at least that's what we think. For now, it's still an option to use. So I guess if you're using batch, you have seen that you can switch back and forth between the enhanced version and the legacy or classic version. When we talk about the feature that I will demo, it will also make the enhanced batch form the default behavior, and that's what you can prepare for coming over time. From PO29, you can also use the saved use feature that is not specific to batch, but in combination with the new batch form, the enhanced one, and the saved use, you can filter and save any kind of filtered views that you want to create, and makes it very easy to navigate and see different information as you need it to. We also added batch alert and notifications, so that enables alert rules when a batch job ends in error or is cancelled, and you can decide whether that should be just shown in the action center or if they should be emailed. And Timo touched on your role in making sure that the performance is as good as possible. And we have two ways now to clean up the batch history in PO25. So you have one that is completely driven by number of days, and another one where you combine the number of days and with filter. So this should give you a good way to make sure that you only have what you really need in batch history. So the main feature I'm going to demo today is the priority-based batch scheduling. It's currently in private preview. It will go public preview from PU37, so that should mean that people should get access to this in late July, early August, and eventually it will become available for everybody. This is important. So right now, even if it's in preview, this is meant to be the new default behavior over time. It won't happen radically, since this is a major change, a major enhancement. So, but I urge you to familiarize yourself early with this feature. If you want to, and you're already not in the private preview, if you want to try this out in a sandbox environment, make sure to send an email with your environment ID, your sandbox environment ID, to the email that we have here, and we will qualify you for the private preview. So what is this feature all about? So this is part of then the decoupling of the batch groups from the infrastructure, meaning that the batch group will not be coupled any longer to batch servers. The same with batch jobs will not be coupled directly to batch servers. Instead, it's using a relative priority to determine the order in which task runs, and it's using at any given time the available batch threads. And your work in this is to prioritize the classification and declare the relative priorities between jobs to optimize so the batch is processed in the most optimal way for you. And I will come back to that in my demo. But it does enable automatic optimization and the use of batch threads. So, and there is even an option for very critical job to reserve batch capacity. So you can set aside a certain portion of your batch threads. Again, it's not focusing on specific or named batch servers. So it will be an allocation of percentage of available batch threads at any given time that will be possible to reserve as an option for specific batch jobs or batch groups rather. So I talked a bit about feature management when I mentioned the batch framework contention reduction. We currently have the batch framework contention reduction being managed, and you need to enable that in feature management if you want to, if you experience contention reduction. You can expect this one to eventually also become part of the default behavior. Then we have in preview. So this is where you need to be part of the preview right now to see the batch priority-based scheduling. And as you see here in the description to the right, this feature takes a dependency on the batch framework contention reduction. So in order to be part and test this feature, you need to first enable that feature. We also have our latest features that is coming out under feature management as part of PU36, and Reva will talk more about that. So time to switch to the demo. So I will start in the feature management, where I now have in my environment enabled the batch priority-based scheduling. Here I just want to call out that if you're using preview features, the documentation will not be available in our normal content, but there will always be a learn more link that if you click on it will open up a description that will cover the content for this specific preview feature. So this will eventually become the new content for this feature, but here you can read all about how to start using this feature, how the logic for batch groups, batch jobs, so on, and it's also describes things that, well, I will cover soon in my demo about reserve capacity, the batch group migration that is really important for you to study. But let's go back to the demo and have a look at the batch groups. So as you see now, the batch group doesn't have any tabs and any relationship to batch servers. What you will see now is a scheduling priority, and you can see all the batch jobs that is using these batch groups. So I've created, just for demo purposes, a group that is using the critical scheduling priority. So if we look at the options that you have, the most common will be to use low, normal, high, and critical. If you use reserve capacity without enabling reserve capacity, it will still be treated as the highest priority. So what does this mean now for your optimization then? So it doesn't mean that the highest priority, like critical in this case, will be always picked when they are ready to be processed. The pooling, loading, or picking logic just means that it's more likely that something with the critical schedule priority will be picked more often than something with high, and it will continue then. So the least likely to be picked at any given time is low. But it doesn't mean that it won't be picked if there still are jobs in critical or reserved capacity waiting, and reserve then given that there is not specific capacity actually defined. If we move on and have a look at the batch job, so this is now by default using the enhanced batch forms. You see there's no option to switch any longer. Here we have the saved view feature that makes it possible for me to create whatever filter and just quickly be able to navigate back and forth. If we go into the specific batch job, you will see now that you have the batch group here, and the default scheduling priority for based on the group then is inherited by the job. It is possible to override. So if I say edit and say, okay, I want to override for whatever reason, I still have the option to do something specific with this batch job, even if it belongs to a batch group that has a specific schedule priority. Looking at the batch tasks, you will still have information about the batch group, and this makes it easy for you in a migration scenario to see how to optimize and plan the relation between batch jobs and batch groups. The way this will be updated is based on a batch job that I'll come back to after my demo and talk a bit more about it. But based on how the recent processing of a batch task has been job, we will use that to associate the batch job to a batch group. Some of the other features that we covered briefly in my presentation, just to point out where they are. If a job is in status canceling, you have the abort option here, and this will become enabled, and you can abort that that job. You see the active periods here being something that you can define on the batch job. You have the alerts where you can configure what should be triggering the alert, just that it's ended, if it's ended in error or canceled, how it should be presented, if there is a need to send an email or not. You control this here. So last in my demo, I just want to show where, if you want to, since it's optional, define reserved capacity. So it's in the system parameters under batch global settings. By default, the option is set to no reserve capacity, but you have the option to set this to low, medium, and high. And moving back to my presentation, we can cover this a bit. So these numbers that you see here is just for illustration purposes. And this is something that you don't control, that we optimize for you behind the scene. So the default behavior again is no reserve capacity. If you set it to low reserve capacity, think about that as somewhere around 10% of the cumulative bed threads that are available at that specific time will be reserved for the batch groups with this setting, meaning reserve capacity. If you set it to medium, it will be around 15%, and if you set it to high, it might be somewhere around 25. The important part here is that this should be used very thoughtful. So this is now like the only way what you might have idle capacity, even if there are batch jobs waiting. So if you don't utilize fully the capacity that you have set aside with batch jobs in these batch groups that is using the reserve capacity, or the batch jobs that are using it, you might still have idle capacity while there are queuing up batch jobs for other priorities. So this is where it's really important to think about this. So it's something to use for super critical jobs where you really want to make sure that they can always get through. You also have to think about the impact of the overall batch situation. So when you enable the feature, it will inform you, as you can see here, about a migration job that is being added, that's being picked up for execution. So what this is doing is assigning the batch group assignment on jobs. So it's looking at the historical execution for how tasks are being executed and is using that for the group assignment. But as an outcome, since we cannot know how the priority should be set for each batch group, it will out of the box be set to normal. So this is where your job comes in. You need to plan and update the scheduling priority for each batch group, and also think about how you actually want the batch group to work given this new behavior. So your work is to make sure that the batch group actually represent the relative priorities according to your business requirements. As I shortly or briefly indicated, we still keep the batch group information on the task as read only for you to have this backward compatibility where you can see based on the historical work, and you can use this to optimize and plan your batch work. But this is really key because this is a major change, and if you do nothing, you just leave it as normal and don't do anything, you haven't taken advantage of this feature. And as I said, this feature will eventually be becoming the default behavior. It will take some time, but I urge you to start planning and using this because this will be a very powerful feature for you to be able to control in a new way how to optimize your batch processing. So with that, I would like to hand over to Reva that will talk about this feature and also what's next for batch.
Thank you, Par. So what's going to come in PU36 is daylight saving time support for batch job active periods. As you see on the screen and the green symbol, the batch job active periods form will have one additional field next to each active period, that is time zone. This time zone that active period would follow from now on. Every active period would initially follow the UTC time zone. The starting and end times of the existing active periods will be adjusted to the UTC time zone. Effectively, what that means is it will run at the same time as before, but the only change that will happen is that the user preferred time zone will become into UTC if it is already not set to. In this PU36, we will also make sure that the daylight saving time adjustments of the time zones are there in place and users doesn't have to worry about it. So, and this is a default behavior that will come on with the active period forms. Moving on to the next slide. So what are the next coming features that are going to be batch? And these are the non-committed features, and we are thinking about it. So your feedback will be really appreciated. We have a Yammer channel where I will be posting these candidates for future releases, and feel free to comment as well as provide feedback there. Starting with the first one, batch scheduling as a microservice. So as most of you know that batch is a standalone single tenant service deployed in Windows that acts only on its data because it's for each of the environment that is talking to. So with batch scheduling as a microservice, what we are going to do is decoupling it with the FNO infrastructure and making it a multi-tenant microservice hosted in the cloud. This will allow scheduling different jobs for multiple environments. And as some of you know that with FNO and CDS combining together, it's a unification of the platform that we are targeting. So this is definitely a cross CAP initiative or the candidate for having batch scheduling as a microservice is definitely going to add and unify the platforms. The next feature that is in place is the batch queue insights. So this will introduce a new insights form in the FinOps web client that would display a snapshot of the sizes of each of the batch scheduling priority queue at any given point. This will allow customers to actually get visibility over their batch schedules so that they're aware of the system health and the processing times of the batch load. This will a unique thing that will be done so that customers are aware what and how their batch load is performing, as well as ensure that they don't overburden the system if there is already a high load on the batch queue. The next item is intelligent scheduling. As you know that we have the AOS server, which does all the scheduler part. So this will give a batch scheduler an ability to assess from historic data that what was the CPU load and the execution time of a batch job. So this will help scheduler to optimize and prioritize based on the past execution time and the CPU load, as well as it will prevent to risk for data loss and the load on the same table. So, for example, if there is any long-running scheduled service operation, if there is a long-running batch job that is scheduled, and if there is also a service operation that is going to, stop the system during the maintenance mode, the batch scheduler will be smart enough to actually not schedule a batch job during that time, because it will ultimately result in failure. So that's about the intelligent scheduling. Moving on, job dependencies. As you know that batch tasks can be dependent on each other and can take action once a job is completed or once job is aborted or something similar to the previous job. Similarly, we want to have a dependency between batch jobs, what we already have between batch tasks. The last one, the dedicated scale. This particular feature is going to enhance how we allocate resources to the batch system. So with the elastic compute, where you can have resources as you need, or downgrading from the resources if you are not having that much of a traffic, this dedicated scale will ensure that you have the enough amount of resources for running your batch tasks and not really overburden the system when you have a higher number of batch tasks running. So with that, these candidates will be posted on the Yammer channel. So it will be good to actually subscribe to that Yammer channel so that you can get all the new alerts, as well as give us feedback about what are the missing or what are the new features that you are going to have in the batch. So with that, we can move on to the next slide. Here are the list of resources that we already have as of today. And at the very bottom, there's a Yammer channel that you can subscribe to. You can search for FinOps FNO batch, where you can see all the subject matter experts, partners, and different people who are fans of batch. Join there. We can have a good discussions about all the different things coming in batch overall, and anything that is required or needed by the users can definitely be posted in there. With that in mind, I'll move on to the next slide. All right, a big thank you for attending this, and over to you, AJ.
Thank you, sir. I just wanted to let you guys know I'm going to post a short link in the chat, the Q&A panel. It's a survey. We do value your feedback on today's session and would like to hear what you'd like to see in future events. The score is on a scale from 1 to 5, 5 being the highest score possible, and it usually takes about less than 3 minutes to complete. So please